and on today's episode, we'll be considering projectiles. Projectiles. Before we commence properly, have you seen a stone being thrown vertically upwards, or a ball rebounding from a wall? What about a bomb dropped from a moving aircraft, an athlete doing high jump, a stone released from a catapult, or a bullet fired from a gun? All these are typical examples of projectiles. What is projectile? A projectile is an object thrown or projected into the air and allowed to move under the influence of gravity only. Underline the word gravity only. Or you can say that projectile motion is the motion of an object thrown or projected into the air and allowed to move under the influence of gravity only. Refer to our channel, we'll drop video on gravitational force. What are the Triune classification of projectile motion? Number 1, motion of an object thrown vertically into the air. 2, motion of an object projected horizontally from a certain height. 3, motion of an object projected into the air at an angle of inclination to the horizontal or vertical. Motion of an object projected horizontally from a height can be seen from our diagram as displayed on the screen. Remember that u is our initial velocity with which the object was projected horizontally. The capital H or the small letter h is the height of projection. R is the range of projection, the distance from the foot of platform or tower to the point of landing. V of y, which is the vertical component of velocity with which the object hits the ground. Two independent motions are combined in this. The first, the motion of a free fall, vertical motion, and then we have the horizontal motion. We can see from the diagram that the time it takes to travel along the parabolic path from the point of projection to the point of landing equals the time it will take if the object were to fall freely through the height, lowercase h. It is also equal to the time it takes to cover the horizontal range, capital letter R. Therefore, the vertical motion is treated purely as a free fall, which is downward motion under gravity. The link to the exegesis on gravitational force is being displayed on your screen above, and the equation of downward motion under gravity are applied directly to it. For the avoidance of doubt, the equations are the Triune fundamental equations of projectile. The first, h is equal to u of y multiplied by t plus half gt squared. Second, v of y is equal to u of y plus gt. The third, v of y squared is equal to u of y squared plus 2gh. All these are conversions from the linear equations of motion, but u of y is equal to 0. Hence, h for equation 1 is equal to half gt squared. When it comes to projectile, v of y is equal to gt, equation 2, and v of y squared is equal to 2gh, equation 3. From equation 3, v of y is equal to square root of 2gh if we take the square root of both sides. For the horizontal motion, the range is equal to u of x, which is the horizontal component, multiplied by time plus half at squared. But in the horizontal, there is no acceleration. That is, acceleration is 0. Hence, a is equal to 0. Therefore, a final equation for the horizontal motion when it comes to range, which is the same thing as distance, r is equal to u of x multiplied by t. The motion of an object projected at an angle of inclination to the horizontal or vertical axis as seen on our screen. The O there is the point of projection, the origin. The U is the initial velocity of projection. A theta is the angle of inclination of the initial velocity to the horizontal axis. U of y is the vertical component of the initial velocity. U of x is the horizontal component of the initial velocity, while our uppercase h is the maximum height reached by the projectile, which is the stone or the bullet. P is equal to the point of landing of the projectile on projection plane. Our R is a horizontal range of the projectile, so that OHP is the parabolic path along which the projectile traveled. Now, U of x is equal to U cos theta, applying SOHCAHTOA, and U of y, vertical axis, is equal to u sine theta. So considering the vertical, which is the upward motion, the time t taken to reach the maximum height h, we have the following. For an upward vertical motion, the triune equations for downward motion under projectile. Number 1, v of y is equal to u of y minus gt, but v of y is equal to 0. Hence, 0 is equal to u of y negative gt. So that u of y is equal to gt. By making time the subject of the formula, u of y will divide g, acceleration due to gravity. But u of y, remember, is equal to u sine theta. Substituting, t is equal to u sine theta divided by g. So this is the time it takes the projectile to reach the maximum height h, and is equal to the time it takes to travel from h to the point of landing, which is point P. Therefore, the total time of flight, uppercase T, is equal to 2 multiplied by lowercase t. Finally, our time of flight will equal 2u sine theta over g. So this is the time it takes to cover the horizontal range. Also, for an upward vertical motion, from v of y squared is equal to u of y squared plus 2gh, uppercase h, which is the maximum height reached, then we can say that v of y is equal to 0. So substituting, 0 is equal to u of y squared negative 2gh. Rearranging, u of y squared is equal to 2gh, but h will now equal u of y squared divided by 2g. But u of y is equal to u sine theta. Recall, so that h equals u sine theta squared divided by 2g. Finally, h equals u squared sine t squared theta divided by 2g. Now, considering the horizontal motion, r is equal to u of x multiplied by time of flight plus half at squared, which is time of flight. We are dealing with range, hence we are using time of flight. But acceleration is equal to 0 for the horizontal motion. Therefore, our range is equal to u of x multiplied by t plus half at squared. R is equal to u of x t, but u of x is equal to u cos theta for horizontal components, and t hence becomes 2u sine theta over g. If you remember, by substituting, r is equal to u cos theta multiplied by 2u sine theta divided by g, so that r is equal to u squared into 2 sine theta cos theta divided by g. But 2 sine theta cos theta is equal to sine 2 theta from mathematics. Hence, r is equal to u squared sine 2 theta divided by g, a maximum range. For maximum range, recall that sine 2 theta is equal to 1. So 2 theta is equal to sine inverse of 1. 2 theta will give us 90 degrees. But theta will equal 90 divided by 2, so that our theta equals 45 degrees. If sine 2 theta is equal to 1 for horizontal range or maximum range, then maximum range is equal to u squared over g, so that our v is equal to velocity of landing, our v of x horizontal components of x, and v of y vertical components of y. Since the shape is a right angle triangle, we can use Pythagoras theorem to resolve the component of v, velocity of landing, which equals square root of v of x squared plus v of y squared. Conclusively or summarily, the time of flight, uppercase t, is the time required for a projectile to return to the same level from which it was projected. Or you can say it is the time taken for the projectile to travel from the point of projection to the point of landing. Hence, the second definition applies to all cases. So the maximum height, uppercase h, is the highest vertical distance attained as measured from the horizontal projection plane. Range, uppercase R, is the horizontal distance from the point of projection to the point where the projectile hits the projection plane again. Or you can say the range R of a projectile is the horizontal distance between the vertical line through the point of projection and the vertical line through the point of landing. The second definition applies to all cases. Finally, trajectory. The trajectory of a projectile is the path along which it travels. It is a parabolic path, and hence the title, the topic is gotten from that parabolic projectile. Connect to our social media handles at Physics Bible, the Triune Physics, for latest update. Thanks for joining us. Stay equipped, stay liquid.